Hi guys, it's Mrs. Seitz, and today what we're going to be doing a little bit of a different activity today. We are going to need a couple different files open to do this activity. We're going to need to open up the Graphing Stories PDF file, and I would like you guys to open that up using Kami. So again, that's Graphing Stories, and I want you to open that up with Kami so that you guys would be able to graph things in there and be able to write descriptions on this document. And then the other thing that you're going to need and have pretty handy with you is this PDF file that says Functional Relationships Handout. Okay. What we're going to be doing in today's lesson is kind of like the baby steps into analyzing and sketching graphs. And basically by the end of today's class is we're going to be looking at some real world situations, and we're going to be able to draw some graphs to represent some real world situations and be able to represent them with graphs without using actual numbers on our graphs. And how we're going to do that is by describing the rates at which certain things happen. Okay, so the first thing we're going to need is to talk about this functional relationships handout. So if you have that open, we're going to take a look at the linear functions that you see at the top. Okay, linear functions have the word line in them. Okay, so the first types that we can see that linear functions, the three different examples that we have, the first type of linear function that we might draw today would be any type of rate that might be happening at an increasing rate, but it would be an increasing steady rate. Another type of situation that we might be drawing today would be a situation that might be happening at a decreasing rate, but the rate might be happening at a steady rate. Another situation that we could be drawing today, and we draw these lines actually a lot, is at a constant steady rate. Okay, so whenever we talk about linear types of things that we're drawing or straight lines, these would be at rates that are steady. Anytime we're going to be tempted to draw a curve in any type of graph that we draw today, these are nonlinear functions. And we've been talking about nonlinear functions in section 5.4, but these type of situations would be when our rates are happening either increasing or overall decreasing, but when the rate is not overall steady. So for example, if I had an overall increasing rate, but it first started really, really fast and then kind of leveled out and went slow. If you wanted to use the next type of curve, we would be saying that it increased overall because you can see it started at the bottom and went up to the top, but then it went from slow and then all the way up to the fast. Okay? The next two graphs that you see, they are overall decreasing because they're starting at the top and ending at the bottom, but the rate at which they're happening is different. So for example, the third graph that you see under nonlinear is decreasing from fast to slow, because if you see, it's decreasing, it's going fast, and then it's kind of leveling out. The last graph is decreasing overall. It's slow, but then goes really, really fast at the end. Okay, and you want to make sure you have this handout near or printed out with you at all times, because it's going to be very helpful to you whenever we're identifying different rates or whenever we begin to draw. And we're actually going to start out with drawing today. So again, it's helpful to have this printed, helpful to have this handy. So if you have this open on a separate tab, that's fantastic. All right, so what are we going to be doing today? Well, we're actually going to be watching a couple of silly videos on YouTube, and we are going to be graphing the rate at which some things happen. So you're going to need, like I said, this Graphing Stories PDF opened up in Kami, and we're going to actually be sketching these different situations. Okay, so here's what's going to happen. We are going to be graphing the situation, but we're going to watch the video first at normal speed. I'm going to pause the video. I'm going to give you a couple of things to consider before you sketch your graph. Then I want you to watch it at halftime. Then I'm going to give you a time to draw your graph, and then I'm going to reveal what the correct answer is. Okay, so we're going to watch our first video. The first video that we're going to watch is about a guy that's just walking over a bridge. So if you guys take a look, it is comparing elevation on the y-axis over time. And a lot of the graphs that we're going to be dealing with today in drawing is the x-axis always is going to be about time. So things that you might want to consider as you're starting to watch this is whenever you first begin to maybe start thinking about the sketch, where is this guy at in terms of his elevation? How many feet do you think he is off of the ground? Other things you might want to consider when you're watching this video. Think about the rate at which he is walking. Do you think you're going to be drawing a straight line? Or do you think you're going to be drawing one of these curved lines? All right, so think about that. And we're going to watch our first video first at normal speed. So just watch it. Don't draw anything just yet. There's no sound on purpose, just so you guys know. Okay, so one thing I think you should notice is down the bottom right-hand corner, the time was elapsing, right? The seconds were going, okay? Some things you might want to stop and think about. The guy was walking over the bridge, right? He stopped, he looked at something, and then he kept on walking. So think about how that could maybe impact what the overall shape that your graph would look like, okay? I want you to watch this now at half the speed, and then I want you to think about what your graph could potentially look like. At the end of this time period, I want you to then draw your graph. So again, notice the time. Okay, now draw your graph. All right, let's see if you're correct. If you weren't correct, you can go ahead and just make sure that you fix that up. Look how high up that graph is. Okay, so I'm going to pause that right now for you to get a moment to go ahead and make sure that you have sketched the correct graph, okay? And then I want us to talk about why this would be the correct shape of our graph. So again, make sure you're fixing up your graph. Okay, so now when we start taking a look at this, okay, when we have the elevation of ours, okay, we notice that he wasn't exactly at ground level. So our graph has to start a little bit more up here, and then we're continuing over. Okay, so it was not just a straight movement. Okay, it wasn't a linear type of movement. Okay, we also want to notice that something happened around here, right? What was this portion of the movement? It was when he paused and he looked over. This section of the graph was whenever, this is maybe part 3, we'll call it. This is part 2. This is when he went back down the bridge. So this is part 1. He went up the bridge. Okay, so he's going up in terms of the elevation. He paused and he looked over. And then part 3, he's going down the bridge. Okay, now if we go back to our relationships, if we start looking at how we drew that, okay, in terms of how that looks, if I look at part 1 and how I sectioned that off, I would say that this would be a nonlinear section, right? And that would be the shape kind of looks like it's increasing from fast to slow in terms of the elevation. Okay. Part 2 kind of looks like it's more constant, right? Because that's whenever he was standing still and he looked over the bridge. And then part 3, that kind of looks like the section of the graph that was decreasing from slow to fast. Okay, so on your paper, I would like you on the description side to make sure that you're writing for parts 1, 2, and 3 for your graph to talk about the rate. So the first part we said was increasing from fast to slow in terms of the elevation. Part 2 was a constant rate whenever he paused and looked over. And part 3 was decreasing from slow to fast. Okay? And again, pause the video if you need to so that you can write those descriptions in there. And you'll get better at this. It was only your first time around. Okay? We're going to do this again. And the second scene, we're going to be looking at a ladder. Okay? So when we take a look at the second scene, again, we're comparing elevation off the ground over time. So when you watch the video the first time, you want to think about when we start the movie, you want to think about where is this guy coming in the picture from? Is he coming in from the bottom or is he coming in from the top? Okay, because that's where you would start your graph. When he's also coming down from the ladder, is it happening at a constant rate of speed or is it something that he's picking up speed with over time? The other thing you might want to think about as you're watching the video, is there anything that's going to prevent him or stop him in terms of his elevation? Okay. All right. So again, when you're ready, you can pause, get ready to watch the video and start making some observations at full speed. And then again, we'll be ready to watch this at half speed and start sketching our graph. So notice he's coming down the ladder. It looks like maybe from the attic. He's pausing to take a drink of some kind of root beer, it looks like. And then he's walking into the kitchen. All right, so again, those are some things that might alter the shape of your graph. Think about when he's coming down the ladder. Is he coming down the ladder at a constant rate of speed, which would be something more linear that you might be drawing? Or do you think he's coming down the rate of speed that would be something that's more nonlinear, so something that would be speeding up? So watch it a little bit more carefully this time at half the speed, and then I want you to draw that graph. All right, so sketch that graph, see how you did. Here's time to reveal what that correct answer is. All right, so guys, when you take a look at that graph, this would be something that is linear because when he's walking down that ladder, it's going to be happening at a constant rate of speed. So he's decreasing coming down the ladder in terms of his elevation at a steady rate. He pauses right here to take a sip, right? So his elevation is remaining constant. He continues to go down the ladder at a steady rate of speed, and then his elevation remains constant as he walks into the kitchen. So what we're going to do is we're going to draw that if you made a mistake or fix up our graph on the ladder, and then we're going to break that apart in terms of description, in terms of the rate. Okay, so again, fix up your graph if you made a mistake. So this is what your graph should look like. Okay. Part 1. Remember, that's whenever he was coming down the ladder. And then he was coming down the ladder. This was decreasing. His elevation was decreasing at a steady rate. So we're just talking about the rates when we talk about the description. Okay, part 2 of the graph. This is when he paused, right? And he took a sip of his drinks, which meant that his elevation remained constant. So when we talk about in terms of the rate, this would be a constant or steady rate. Okay, for part 3 of the graph, that's a decrease at a steady rate. And then finally, part 4 of the graph, this is another flatliner, right? So this is again where he's reached ground level of the first floor of his house and he's walking into the kitchen. So his elevation is remaining at a constant rate. So you always have to remember what you're comparing. In this graph, we were talking about elevation off of the ground. So we're not talking about how fast he was going. We're talking about how fast he was decreasing his elevation. All right. If you look at the next one, a lot of people like this one. The guy in the video has a hammer. And if you take a look, we're going to be involving some pain in this one. So we're going to be comparing our intensity of pain over time. So think about like if you've ever, hurt yourself and you ever have to go to the emergency room and the first thing they ever ask you is on a scale from 1 to 10, 10 being the worst pain you've ever been in, 1 being the lowest amount of pain you've ever been in, what would be your scale of pain? Okay, so that's what I want you to keep in mind as you're watching our next video with the intensity of pain. So obviously he's clearly faking. However, some things I want you to think about before you start drawing your graph. What are some things that we might need to consider with our graph, right? The level of pain doesn't start happening right away, right? He's just starting whatever his project is for a little bit. I want you to notice the time in which he the accident occurs. And then think about whenever you had hit yourself with a hammer, would the level of pain be instantaneous or would it be gradual? So I want you to think about that because that would impact the type of graph that you're going to make. Is it going to be more linear as his pain increases, or is it going to be non-linear? So watch it one more time at half the speed. So notice the time. Okay, so 13 seconds in. All right, draw your graph. Let's see what this answer looks like. So notice the graph has started. There's no pain. And there we go. So there's what your graph looks like. So when we draw this graph, you can see that at the end, it does have a little bit of a curve to it. So when we draw this graph, let's consider that at the end. So when we draw it, the level of pain is a flat line to begin with. And then towards the end, it kind of tails off like this. So it does have more of a curve toward it. Okay, so if we're going to break this graph into two different little sections in terms of the rate at which the pain is happening, the first part, if we're comparing the rate, it's a flat line, right? So if you want to go back to those relationships handout, you can see that as a constant rate, okay? So no pain is happening there. So the first one is a constant rate. The second part of our graph, we're going to go into the nonlinear section because it's a little bit more curved, okay? And if you look at the type of nonlinear section that matches that, it would be the one that's increasing from slow to fast. So when we look at that, think about the type of pain, okay? It's overall increasing, right? From slow to fast, right? So the pain's happening, overall it's increasing. It starts out a little bit of pain, and then over time, that's really, really throbbing, and it's getting hurt. It's hurting really, really bad. Okay. So that's why it would be more of a non-linear type of description. All right. The last video, and hopefully you guys are getting better at drawing these. The last video that you guys are going to watch today is of a runner. Okay. And this time you're going to be comparing distance over time. So that's what you need to think about, distance along the road over time as you're watching this last video clip. Love how he runs, by the way. You're allowed to laugh. I call him Forrest. If you've ever watched Forrest Gump, you know what I mean. All right, so right now, guys, see if you can graph it. Okay, was there anything blocking him? Is there anything at all that could change the shape of your graph? All we're doing is comparing distance over time from the starting point to the end. Okay, let's watch it at half the speed. All right, let's see if you got your answer right. Sometimes people make a mistake on this one because they think the curve in the road has something to do with it, but it does not, because we're just comparing the distance along the road over time. Okay, so that curve actually has nothing to do with the shape of the graph. So all we need to do on this one is, and if you made a mistake, just fix it. Just draw a straight line on that one. Okay, and there's only one section of a rate that we're talking about. So his distance along the road is increasing at a steady rate, according to our paper. Okay, so hopefully you guys are starting to get a little bit better at drawing some of those. Okay, and that will help us big time with the next activity that you are going to be doing today. So before you do our next activity, make sure you are finishing up your drawings, make sure you are writing down the rates that we just talked about, and then making sure you are turning this in.